In this tutorial, we're going to go over how to recreate a drawing of the Titan 6M. First, let's take a look at the example drawings from Titans of CNC. Sheet number 1, we have our basic shape of our circle with a diameter of 1 inch, 950 thousandths. We have our front view here indicating the thickness of the part. Moving on to sheet number 2, we have our bolt hole circle with our start angle, and then we also have some dimensions of our through holes. Sheet number 3, we have our top view showing that we have these squares here. We have a little detailed view indicating that there is some radiuses over here. And that looks like it's pretty much it. So let's jump over to Fusion 360 and create this drawing. I'm over in Fusion 360. Make sure that you first have your part saved. Otherwise, Fusion 360 will not allow you to create a drawing from it. We're going to change our workspace into our drawing workspace. Very first thing Fusion 360 is asking for is, do you want everything in this workspace to be on your drawing? Yes, we do. We are creating a new drawing, and the template that we're going to be using is the template that we created in another video. And then we're going to press OK. Very first thing that Fusion 360 is doing, or wants to do, is it wants to land our front view. We're actually going to change our scale of this part because this part's pretty small. We're going to go to a 2:1 scale, and we are going to be using visible and hidden lines on this particular part. We're going to land this part, our front view, kind of in this area here, and then press OK. After we have our front view, we're going to go back to drawing views into projected view. I'm going to click on our front view and drag our mouse up, landing that view, and then I'm going to drag it over, landing an isometric view, and then press enter. We're going to double click on our top view here, and we're going to change the style from parent to just visible lines, and then close that out. And then we're going to change the style over here on our isometric view from a wireframe to shaded with visible edges. Now that we have our three views in place, now we're going to start adding in our dimensions. Let's first take a look at our front view. We're going to go to ordinate dimension, and we're going to click on this, the very top of our part here, landing our datum location. Next line that we're going to click on is the top of our flange. We're going to reference off of the line here so everything lines up perfectly. And then lastly, we're going to come off the bottom and then reference off of the previous measurement, just like that. One thing I want you to look at is look at your annotations. Currently, our annotations are indicating that we only have 2 digits to the right of the decimal place. We actually want 3. We're going to go down to the bottom center and open up our annotation settings. We're going to turn display trailing zeros on, and then change our linear dimension precision to 1, 2, 3. Once we do that, notice our 0 has changed. We're going to double click on it and change its primary precision to just 0. Our front view is pretty much fully defined now. Let's look at our top view. Our top view here, we're going to go D on the keyboard, and we're going to set our diameter of our part right over here in this corner. Next thing that we're going to do while we're in here is we're going to set the distance between these two islands. I'm going to drag this up here, right about there. And then I'm going to drag our dimension out and put an extension line there. Okay, one thing that I want to do is I want to put in a bolt hole circle. So we're going to go in and go to Geometry, Center Mark Pattern. We're going to click on, let's see, we're going to click on these holes here. So notice I clicked on 3 of these holes and it picked up the 4th one automatically. And then I'm going to press enter. Oops. Notice it didn't pick up the 4th one. We may have to add that one in and then press enter. That's looking better. Okay. Now that we have our bolt hole circle here, we can reference off of it. So D on the keyboard. We're going to click on that circle there and drag our mouse up here. And for some reason our dimension's off. Oh, no, it's not. This particular dimension, it's giving us a radius amount. Actually, I want a diameter, so I'm going to go to Dimensions, down to Diameter. I'm going to click on that, and then that will give us a diameter measurement. Once I have this in here, I'm going to double click and type in BHC, indicating that's the bolt hole circle diameter. Over here on this island, I'm going to put in a detail view. I'm going to go to Drawing Views, down to Detail View. I'm going to go right from the center and drag my mouse out and land this detail view. And I'm going to drag this over kind of up in this area and then press OK. Now, if you made a mistake, kind of like what I did, is you can always come in and readjust your detail view as needed. So for example, I'm going to drag this down a little bit, and then I'm going to position the A on the other side. And then now our detail view is looking a lot better. I'm going to drag this over. All right. Since we're here, we're going to go D on the keyboard. We're going to give us a dimension off of this. So here's our 375 thousandths. I'm going to right click, double click on this. There are 5 of those that share that feature. And we're going to insert a symbol indicating that is a squared part. And while I'm here, I'm going to move the location of this A again. There we go. That's looking better. Up here in our detail view, we're going to go D on the keyboard. We're going to reference off of this radius, drag that out. The other thing that we're going to do is we're going to add in a center mark for our bolt hole, and then D on the keyboard, and then we're going to reference off of that center mark, giving us some dimensions here. Now all of our squares all share the same radius, so we're going to put TYP in front of it. And lastly, we need to put in our dimensions for our holes, and we also need to put in our start angle. So to get our start angle, what we're going to have to do is put in a center line. And this particular center line, we're going to go from these two lines here, and that gave us a center line. I'm going to go D on the keyboard. I'm going to reference off that center line and over to this angle here. And there's our start angle. And we can even label this as our start angle. And so now that we have our start angle in, we're going to label our hole diameters. So we're going to use a text with the leader line. We're going to come right off the center here. This particular hole was 250 thousandths, and there's 4 of them, so 4x, the diameter symbol, 250 thousandths, and then we are going to label that this goes through the part. My arrow kind of went in the wrong location. I'm going to drag that over like that. And then we're going to put in another text with the leader, dragging this one over here. There are 5x, so there's 5 of these. These are 1032 unified fine class 2B threads. These threads go 150 thousandths down. And we're going to enter the depth symbol, and then we can close that out. Lastly, this particular part is a little bit redundant, but we can add it in. It's redundant because it is stated in our notes that we want the part to be completely chamfered and all sharp edges are broken. But we can come up to text with the leader, and we can click on this edge, and we can type in TYP 10 thousandths 45 degrees chamfer. And that will take care of our chamfers there. Lastly, we're going to update our title block. We're going to click on the lines of the title block. There it goes. Our material that we're using is 6061 T6 aluminum. And then this is revision A. And then hit OK. It's a good opportunity. Double check your part. Make sure it's very easy to read. And this concludes the tutorial on how to make a drawing for the Titan 6M.